Hello, welcome back to part 3 of the series for hard surface modeling for visual effects in Maya. In this episode, what we're going to take a look at is a couple modeling techniques that we use while modeling for hard surface, and these will include edge hardness, edge flow, and a few topology tips, mesh smoothing, and subdivision modeling. And I won't explain too much about what those are now because we'll get into it a bit later in the video. But yeah, so we're just going to go over a few modeling techniques and we'll dive right into edge hardness. Okay, so what we're going to take a look at today, just to begin with, is a few different modeling techniques. To begin with, what we're going to take a look at is edge hardness. Okay, so if we go ahead and just create a cube, all the edge hardness is if we look at the edges of our cube here, right, you can see they're perfectly sharp. Okay. Now, nothing in nature is perfectly sharp like this. You get very, very sharp objects like diamond and things like that, certain stones. But there's always going to be some curvature to the edge. So when, light's shining on it, you'll see some sort of like bevel to the edge, okay? So what is important to do when you're modeling, specifically, or especially for VFX, is whatever object you make, whenever you have edges like this, is to make sure that they don't have hard edges. And there are some cases where you would leave edges like this, particularly if you were modeling something for a background. It was going to be seen from quite far away, then you could get away with this. But if it's going to be something that's quite hero, quite seen up close on camera, then you want to make sure that you just make these edges not as hard. And the hardness of the edge is going to depend on what the material is. So if it's a wood, it might have a softer edge. If it's like a refined machined metal, it might have quite a hard edge. But all we'll do is, like we were looking at in the previous episode, is we'll go and select all our edges. We'll bevel. We'll reduce the fraction of this a little bit, say down to something like this. And then what we're going to do is just add 2 segments. And then there we go. So now what we have is a much less sharp edge. It's far less hard. There's some smoothness to it, and it just kind of makes the object look more real, less CG. It does look very CG with the particularly hard edges, and you can do your bevels like this on objects. But what I would encourage you to do instead, actually, is if we just undo this, we go ahead and redo our bevel. Reduce the fraction again down to something a bit more appropriate. And then instead of going and adding 2 segments like we did before, if we just leave that on 1, and we go and turn off chamfer here. Now all that chamfer is it's essentially just cutting away a piece of the edge like this, creating an angle on the edges. But if we disable that, then what that's going to do is add these kind of holding edges here, these edge loops. And you could do this manually by hand as well if you wanted to. But the reason I'd say to do this instead is just because when it comes to actually subdividing the object, which most meshes normally will be, particularly if they're going to be seen up close in film or TV, is that it just maintains the shape a bit better. If we had gone for the rounded edges and this gets subdivided, then the edges aren't held quite as well. It'll roll over, but with it like this, they tend to hold a lot better. Yeah. Okay, so the next one we're going to take a look at is edge flow. So essentially what edge flow is how the edges of your mesh travel across a piece of geometry. So a lot of this will already be defined by the shape and how many subdivisions you have, but you can also define it yourself. It's very important to control it yourself, especially if you have a more complicated mesh. You don't want to have edges going all over the place, especially where you don't need them. You don't want parts of a model to be unnecessarily heavy. You might have edges from one area getting to another area where you don't want them to be and messing up with any other shapes that you have. So what we're briefly going to have a look at here is a few examples of reducing edge count and redirecting edges into a different direction to kind of control that edge flow. So we have a few examples here. So we have this one. We've got a few edges here going along this plane. And what we want to do is reduce the number of edges we have coming out here. Let's assume we have something down here and we don't want all 3 of these. So what we can do is, just for example number 1, is grab these 3 vertices. And like we talked about in one of the previous videos, we can go ahead and merge these or target weld these. So we could grab, the target weld tool and just merge these two in to the center here. Okay, what you can do instead of using the target weld tool is you can come up to edit mesh and go to merge to center, and that will just quickly do the same thing, a few less clicks. And then we can do the same down here. And then what we'll just do is we'll go to edge selection, select this edge here and delete this one. And now what we have here is just a quad, in the shape of a triangle, but for all intents and purposes, it's a quad because we have 4 vertices. And yeah, what you can see is we've reduced our, 4 faces, 3 edges here, down into 1 edge and just 2 faces, okay, which can be much tidier. An alternative to this would be, let's say we go ahead and delete these 2 edges, okay? A quick little tip, when you're deleting edges, you could just press delete on the keyboard, but if we go to vertex selection, what you see is we still have the remaining vertices here left over from those 2 edges. So instead, if what you do is select the edges you want to get rid of and press Control Delete on the keyboard, go back to vertex selection, you can see those are now gone. I would say if you're planning just to get rid of an edge entirely, which most of the time you will be, press Control Delete instead, because it saves you headache of just having random vertices later on that are going to mess with your models. But yeah, so we've deleted those 2 edges. What we can do now is if we go to the multi-cut tool, holding Shift, we can put this new edge here directly in the middle. Then if we go to vertex selection, target weld, and just bring these out to the side here, what we've done, like with this one, we've converted our 3 edges into 1, but just in a slightly different way. We have, a few more shapes here now, a few more faces, sorry, a few more quads, but it's done the exact same thing and converted that down into 1 edge, 2 faces. And the decision to use either of these, it's kind of up to you really. It will depend on the mesh that you're making, whether it's a smooth or a flat surface. These are things you kind of have to take into consideration. If it's a smooth object, sometimes this kind of shape isn't necessarily going to be helpful. When you come to smooth it, you might be getting artifacting. We can go into that sort of later, but edge flow really does play a huge part in that. Alternatively, let's say we have a shape here with 2 edges running down the middle, okay? Instead, what we could do is we could just select our edges, go to target weld again, and just bring these out to the side like this, okay? And yeah, that's created some triangles, and what you might hear from some people is that triangles should be avoided at all costs, and they're evil. That's not true. If you're doing character modeling, or if the model has to deform or smooth and maintain like a perfect curved shape, if it's quite reflective and you don't want any deformation, then yes, that's the case. But on a perfectly flat surface like this, we don't have to worry so much about having perfect quads. We can get away with triangles, right? The topology on the inside of this shape here can basically be anything within reason. So long as there are hard edges on the outside, you're not going to see any deformation. I would encourage you to maintain quads anyway, just because it's cleaner, better to work with. If you do have to cut up a model or edit it later, then it's easier to work with. But this kind of thing here with some triangles, that's really not a huge deal at all, unless it's deforming. Okay, so to just carry on from what we were talking about previously with edge flow, something I kind of neglected to mention was redirecting edges. So previously we'd gone and had a look at reducing the number of edges, so we have less further down here. But what we can also do, say, we have some geometry over on this side, we need an extra edge, we could potentially, redirect one from here. So let's say we want to get rid of this edge on the right-hand side. So what we can do, we just come here, Control Delete these so that the vertices are gone as well. Then we're going to go take our multi-cut tool, insert this here, and just run along. Now to add this perfectly center, we're holding Shift on the keyboard. Now what we're going to do then is go to vertices, target weld, and just target weld that to the right-hand vertices. So what we've done now is we've taken this edge from flowing down here and we've redirected it to go to the left here, okay? And then we've just taken, part of this edge and target welded it to create quads. So now we've got this nice even quad topology, and we've redirected our edge to go over into this direction to be used, for whatever we might need it to. Another example, this is kind of what we did before. We're just going to be reducing the number of edges down here, but just this will be more of an example of why we might like to do that. So let's say, for example, down here, we want to create a circular shape, a circular inset, okay? But, you know, perhaps we don't want this center edge here, okay? Maybe we just want to create a circle with these 4 faces, or with 2 faces here for whatever reason, and we don't, you know, need this center edge. So what we can do is we'll go ahead and just take these 3, okay? We will go to edit mesh and merge to center to get rid of those additional edges. Then we'll come here, and you know what you can do when deleting edges is just, you know, double clicking this to do edge loop and control delete. Alternatively, what you can do is using marking menus like we spoke about in a previous episode. So if you hold down control on your keyboard, hold down right click on the mouse, and then it will bring up this menu. What you're going to want to do is go to edge loop utilities and to edge loop and delete. And what that's going to do is essentially the same thing as double clicking the edge, pressing control delete, gets rid of the vertices, but instead, you know, you're just selecting one edge and then very quickly getting rid of it. And this might not be faster for you to begin with, but you know, once you develop the muscle memory and you get used to doing it, it will become much quicker, much more intuitive, and it's generally what I do to speed things up. So yeah, what we've done, as you can see, we've converted this into our quad here, our triangle quad, reduce the number of edges down here, and then now what we can go do is just take these, you know, what we'll do is just extrude in and create our circle shape. This little tool here, we haven't really spoken about this, but this, you know, if you select some faces or even vertices or edges, even any part of a mesh on an object, and you press this button up here, circularize, it will just convert that selection into a circle. So yeah, what we've done is we've reduced some edges and then add a circle down here. So that's a potential use case, a simple one, but just to give you an idea of why you might want to reduce edges on certain parts of your mesh. You know, if you imagine up here, we might have some more detail that require all these edges, but down here, not so much. And we want to add this circle, little detail here, but we don't want it to be particularly high poly because we're going to be smoothing it later anyway. Then, you know, you could do this. Okay, so the last one we're going to take a look at in this video is subdivision modeling. So I may have mentioned this in the past couple videos, but essentially all subdivision modeling is we're taking a mesh, we're keeping it as low res, as low subdiv as possible for as long as possible, and then just simply subdividing it at a certain point, normally at render time. You know, anytime anything's rendered within VFX, it's going to get subdivided a few times. But subdivision modeling mainly, you know, you can use it while you're working. So just as an example, let's say we want to create a curved shape here with what we have. So you might go ahead and do, you know, we'll select this edge, go to the modeling toolkit, bevel it, add a few divisions, you know, and then now we have that curved edge. But alternatively, what you could quite easily do is just keep this low poly shape, go to smooth, and bam. Okay, so now instead of doing the whole bevel, you've just kept the low poly mesh, subdivided it a few times, and now we have a curve. And you know, maybe it's not exactly what you want, but you know, you could go ahead and then edit again, since it's pretty low res, you know, moving these vertices around. But that is perhaps the most basic example of what subdivision modeling is. It's taking, you know, let's say you have an object in mind, making a very low res basic blocky you know, representation of it, and then just smoothing it to get the final shape. And a way you can do this quite quickly without having to worry about, you know, permanently smoothing your object and having it being destructive is if you just press free on the keyboard with your mesh selected, what it will do is it will show you a smooth mesh preview. This is not actually subdivided. This is just purely a preview within Maya. You know, if you export this, it's not going to look like this. It's going to look like this. But to quickly work things up in Maya, you can press free on the keyboard with your mesh just to see if your blocky version kind of subdivides into what you want. And then once you're happy with the shape, you can go ahead and press 1 again on the keyboard to return back to the regular version, and then press smooth. You know, another example could be with a cylinder. But I guess what we'll get into next is modeling a bit with subdiv in mind. So let's say we wanted to punch a cylindrical hole in this object. Okay, so what we could do is if we take our cylinder, rotate it, make it a bit smaller, And then, like we did in one of the previous videos, if we boolean, just to get that hole punch out, okay, and then we'll just go ahead and delete some of these vertices, it's not vertices, sorry, faces on the inside. And we've got some topology cleanup that we have to do here. So we'll quickly do that. Like we mentioned a number of times, it's important to maintain quads as much as you can. You know, we don't want these n-gons, particularly when working with smoothed objects like this. So now we have that shape. And then what will happen when we go ahead and smooth this? Actually, before we do that, let's quickly add a bevel on top of here, just to further get this point across. Okay. So if we go ahead and smooth this, actually let's add one more here. So if we go ahead and smooth this, this might look okay, but if we go ahead and apply a new material, like a thong, that's quite reflective. You can see we're getting kind of some weird deformation in areas around here, okay? It doesn't look 100% smooth. It's looking a little bit funky. You can see how here it's kind of bowing out. It's not maintaining that perfectly flat shape anymore. And the reason for that is, whenever you're working with subdiv modeling, it's taking all of these edges around here into account, and it's kind of interpolating, averaging it out, and then giving you that final shape. And what the issue is here is that we don't actually have enough topology, enough edges around this hole to maintain the original smooth shape of this cylinder while also having this smooth cylindrical cutout. So what we can do to fix this is, if we just undo all of this, in fact, actually, you know what, we'll just create a new cylinder. And so initially what we had was a cylinder with 8 sides, okay? What I would say to do instead is just bump this up to something like 24 sides instead, maybe. I mean, a lot of this comes with trial and error, figuring out, you know, how many you need for this kind of thing. And then what we do is go and create another cylinder and just essentially redo what we did before, punch that hole back out. Whenever you're doing this kind of thing, it's important that the object that is going to have the hole punched in it is normally higher res than whatever the hole punch will be. So we'll take an 8-sided one here, and we'll just scale that down until it fits within the object. Then we will go back and boolean again, go to difference, and then we have a hole punch again. And then what we'll do is we will just briefly, like before, clean this up a bit. Add our bevels. Delete some of these faces because we don't need these right now. Then what we have to do next is, because we now have a few more subdivisions on this cylinder in the first place, is we're going to have to do a bit more cleanup than before. So if you were to do something like this, ideally what you would do is, if we add 2 cuts along here, the reason for this is because whenever you're doing subdiv modeling, or just modeling in general, you kind of want to maintain square faces as much as possible. You know, you don't really want these really long faces like this, just because when you do go to subdivide, or if you need to deform this later, they don't always play very nicely. They can look a bit odd. You can get some strange shading artifacts. And it's just generally cleaner to work with. You know, it can even affect when it comes to doing texturing, UV mapping, but we'll get into that a little bit later. So what we'll do, just finally, is target weld a few of these edges here, and then delete some of the unnecessary ones. We have one final set of edge lips to add, just here to connect these up. Okay. Now, if you go ahead and apply that same material we added earlier, and just on a quick note on that actually, whenever you're modeling curved objects like this, I would encourage you to apply a shader like this that has some kind of shine to it, because it means whenever you do go to subdivide, you're quickly going to realize if there's any shading artifacts, subdivision artifacts. You're not going to see it as much of a flat shader like the Lambert over on this. So if we go ahead and smooth that now, you can see how way less artifacting. We've now got this straight edge as we did before, and it's a much smoother object overall. So while it is important to keep your meshes as low as possible, occasionally, it's almost always with curved objects actually, you want to have a higher subdiv level to begin with, before you start going and adding details in like this, like hole punches. Square holes can be a little bit more difficult than this, because imagine we have a square and we want to maintain that square shape, then you'd have to have supporting beveled edges on each edge of the square to maintain its shape. And then for that to work without any artifacting, we'd have to have even more subdivisions on this cylinder, maybe like 64, something like that. But it can just kind of be a bit of trial and error. It took me a long time to figure that out. But you just eventually end up finding out what works. And then when you have to make these shapes, you kind of just know, you have like a catalog in your mind of what works and what doesn't. Okay, so that about wraps it up for part 3 of this video series. And we've gone over a few things, some modeling techniques, some processes, edge hardness, making sure that our edges aren't perfectly hard, because no objects in real life are, even if it's a really, really solid object like machined metal. Edge flow and a few topology tips, right? So redirecting edges into different directions, terminating edges to reduce the number of edges we have later on in a mesh on another part, and a little bit as well on mesh smoothing, subdivision modeling, and making sure that you have enough initial subdivisions in your mesh before you start adding detail like insets and so on. So yeah, any questions, don't hesitate to ask in the comments. I'll be happy to answer pretty much anything you want to ask within reason. Yeah, in part 4 of this series, what we're going to do is we're actually going to start on a project. I haven't fully decided what that is yet, but essentially what we'll do is we'll, from start to finish, go through how we would tackle this project within a VFX Studio environment, and by the end of it we should have a complete model up to the kind of standard you'd expect. And yeah, it should be a bit of fun. So until then, I'll see you in the next video.